Hello, good morning everybody. I am Manjula, lecturer in Science, Smt.J Government Polytechnic, Bangalore. I am going to teach you the industrial chemistry part for you, which is in the applied sciences subject. So this is the sixth unit, that is the last unit. So the contents units you are having in the syllabus and the last unit part, industrial chemistry, I am going to teach you. The topics which are covered in this unit are electrolysis, corrosion, batteries, fuel cells, metallurgy, polymers, composite materials, solutions, and pH value. So, my part is electrochemistry. So, electrochemistry is nothing but the branch of chemistry which deals with the conversion of chemical energy into electrical energy and vice versa. So we have got its application in industries and in many other fields. So in that, we are going to take some only few topics in electrochemistry. So before going to directly to the topic, should have some basic ideas about the conductors and the electrolytes. So let us take about conductors. So we know that conductors are nothing but the substances which conducts the electricity through them easily. And in conductors, we have mainly two types. Metallic conductors and electrolytic conductors. Metallic conductors, as you know, are the metals in which the flow of electrons will contribute to the electricity. So as the word suggests that the metallic conductors are nothing but the metals in which the current flow will be with the help of the flow of electrons. The other type of the conductors are non-metallic conductors, also called electrolytic conductors, or sometimes it's also called as ionic conductors. So here in electrolytic conductors, the flow of the current will be with the help of ions. Ions will carry the electric charges, and with that help, the electricity will be flowing. So we are related, our topic is related with the electrolytic conductors and not with the metallic conductors. We have electrolytes. Electrolytes. These are the substances or the compounds which allows the electricity either in the solution form or in the molten form. And when the current is passed through them, they undergo chemical decomposition. So by when the electrolytes are say dissolved in the water, they are going to dissociate, are going to separate into the respective ions. This process of splitting up of a substance into their respective ions is known as ionization. Ionization. So, electrolytes dissociate into their respective ions when dissolved in water. So, the process is known as ionization. So, what are the electrolytes? So, we have got acids, bases, and salts or as electrolytes. Say for an example, we have HCl, hydrochloric acid, H2SO4, sulfuric acid. So acids are electrolytes. NaOH, sodium hydroxide, KOH, potassium hydroxide. So which are bases, and salts like sodium chloride, NaCl, and copper sulfate, CuSO4, which are salts, are also electrolytes. So electrolytes are nothing but ionic compounds. We have some types of electrolytes. Types of electrolytes. They are strong electrolytes and weak electrolytes. Strong and weak electrolytes. As the word suggests that the strong and weak, it refers to their ionization power. There's nothing but the strong electrolytes are the electrolytes which is completely ionized in the solution. Means if that electrolyte is dissolved in water, it is completely going to be splitting up into the respective ions. Almost 100% will get separated, and that is called as strong electrolyte. Say for an example, we have HCl, hydrogen chloride, NaCl, sodium chloride, and NaOH, etc. are as strong electrolytes. Next, weak electrolytes. Weak means which are not completely dissociated in the solution. So weak electrolytes are the substances, are the electrolytes which are feebly, which are not completely ionized in the solution. And in that case, they'll have the low electrical conductivity. Means the whole ions, if the percentage of ions liberated is not completely, then what happens? Obviously, the conductivity will be less. So its conductivity will be less in case of weak electrolytes. So example for weak electrolytes are acetic acid, ammonium hydroxide, benzoic acid, etc. Apart from electrolytes, we have non-electrolytes. Non-electrolytes are the compounds or the substances which do not conduct the electricity either in the molten form or in the solution form, and they do not undergo any chemical decomposition by the passage of current. So whatever you do, if you dissolve it in water and if you pass the current, so nothing happens. So no ions are liberated in that case. So such substances are known as non-electrolytes. Example for non-electrolytes are benzene, ethyl alcohol, carbon tetrachloride, etc., which are almost the most of the organic compounds are non-electrolytes. Next, we have a very important phenomenon in electrochemistry, which is electrolysis. Electrolysis. What is this electrolysis? It's nothing but the decomposition of an electrolyte due to the flow of electric current through the solution of the electrolyte or through the molten electrolyte. Means I have say an electrolyte, say for example, I have got sodium chloride. Sodium chloride, which is an electrolyte. When this is dissolved in water, in sodium chloride, which is your common salt, is dissolved in water, it is going to split up into its respective ions, which are Na plus sodium ions and Cl minus, that is chloride ions. So these are called as the ions in which Na plus is positively charged ion and Cl minus is the negatively charged ion. And say that solution I have taken in a beaker, and we have got two plates, or we can have it in the form of rods also, called as electrodes. So these electrodes, when they are connected with an external battery DC source, to have a potential difference between these two plates, that is these two rods, so the current flows even in the solution by making it as a closed circuit. How? See, we have got sodium and Cl, so Na plus and Cl minus ions in the solution. If there is no current, so then what happens? The ions will be just in the solution. So they will not do any other things, just splitting up of the ionization. That is splitting up will take place. And if we are provided with a battery, the charged particles will move towards their opposite electrodes. That is, this is being positively charged electrode and this is at the electrode, negative electrode. So our Cl minus ions are going to move towards the positive electrode since they are having opposite charges, and Na plus ions which are having the positive charges, they move towards the negative of the battery, that is the negative of the electrode, negative plate of the electrode. And like this, they get separated. And these two are going to deposit at their respective electrodes. So this process is known as electrolysis. So the decomposition of our NaCl is taking place due to the flow of the electric charge, so electric current through the solution. So I have given a video. I have a video which shows that the electrolysis of sodium chloride skip it. Sorry, the video is unable to get displayed. So we can move on to our next thing, that is Arrhenius postulates of electrolytic dissociation. In 1887, the famous scientist Arrhenius, he explained the phenomenon of electrolysis by explaining the behavior of electrolytes and non-electrolytes. This theory is also known as electrolysis, electrolytic dissociation, or Arrhenius postulates of ionic theory, or Arrhenius postulates of electrolytic dissociation. So his postulates will explain us the mechanism of electrolysis. So the laws or the postulates or the theories which explains Arrhenius ionic theory are given one by one. So the first one is when an electrolyte is dissolved in water, some of the dissolved molecules dissociate into their electrically charged particles called ions. This process of splitting up of an electrolyte in the solution into ions is known as ionization. So the first postulate gives us almost the definition of ionization. So the example which I had given will explain us about the ionization. That is, this is the electrolyte, sodium chloride. So when this is dissolved in water, so it is decomposing into sodium, Na plus and Cl minus ions. So that is about our first postulate. So which gives us the definition of ionization. Next, these ions are named differently because if we call them as just ions, positive and negative charged ions will behave differently and hence they are named with different names. So the negatively charged ions are known as anions and positively charged ions are known as cations. Cations. The naming of the ions is our second postulate of Arrhenius theory. That is, the positively charged ions are called as cations and negatively charged ions are known as anions. And in the solution, the total number of anions will be equal to the total number of cations. It's so common, isn't it? I have got a solution in which say I have got the salt, sodium chloride, which is a molecule. When this is dissolved in water, it is going to split up into Na plus and Cl minus ions. So whatever the number of Na plus ions I have got, the same number of Cl minus ions also I have, isn't it? So that's why the total number of cations will be equal to the total number of anions in a solution, And if the solution, if I take as a whole, it will be always electrically neutral, as the number of cations are equal to the number of anions. The solution will behave as a neutral solution. Next, so how do we get this charge plus minus? So it's not always only one plus and only one minus. It differs from different substances. So that is, the charge carried by the ion is equal to the valency of that atom. So valency, I think you know the definition is nothing but the number of electrons in the outermost shell, isn't it? So whatever the number of free electrons we have in the outermost shell, that is the valency of that atom, but that gives us the charge for that particular ion. So that is our third postulate, which gives me the charge is equal to the valency. So charge carried by an ion is equal to the valency of that radical or atom. Next, fourth postulate tells that the entire electrolyte is never ionized. Only a part of it is ionized, and the percentage of total number of molecule of an electrolyte which is ionized is known as degree of ionization. Means the whatever the number of molecules I have got, and with that, so what is the number of molecules which are ionization? The ratio, the percentage if you take, it's known as degree of ionization or degree of dissociation. So that is our fourth postulate about degree of ionization. Next postulate tells us about the ionization, which is a reversible process. Means at one place, say if the molecule is going to split up into their ions, at the other place, these ions are going to combine or unite to form their respective molecule. So as we are seeing, say sodium chloride, it is going to split up into sodium plus and Cl minus ions. So at one place, the molecules are splitting up into their respective ions. At the other place in the solution, at some places, these ions are going to combine to form their respective NaCl molecule. Means it is a reversible process. That is, ionization is a reversible process. Next, these ions are responsible for the carrying of electric current in the solution. So as I told you, in metallic conductors, the free electrons are responsible for the passage of current. Whereas in our electrolytic conductors, these ions are responsible for the passage of current. So that is our ions responsible for passage of current. So like this, we have some postulates of Arrhenius electrolytic dissociation, which gives us the phenomenon of electrolysis, the ionization, the naming up of the charged particles, and how the process takes, and so on, given by Arrhenius. So next we have mechanism of electrolysis. Mechanism of electrolysis. So I'll take the example of same sodium chloride, that is NaCl. So in this electrolysis, as I had explained, I have to take sodium chloride solution and the electrodes are connected with an external DC source. So what happens here? As I had explained earlier, so the anions and cations move towards their opposite electrons. That is, the negatively charged chloride ions move towards the anode plate, that is positive electrode, and sodium ions, which are positively charged ions, they move towards the negative electrode, that is towards the cathode plate. So we are seeing two different reactions at electrodes, two different electrodes, that is at anode and cathode. So this is anode, this is cathode. So let's see how this reaction takes in these two different electrodes. So the reaction at anode, the reaction at the anode. Here, Cl minus ions, chloride ions, move towards the anode plate. So there, Cl minus ions will give its one electron to that anode and becomes chloride radical. A radical is nothing but an atom or a molecule which is having an unpaired electron, means which is not stable. So by giving its one electron, it becomes a radical which is not stable. So two such radicals combine to form chlorine gas, which is liberated at the anode plate. So whatever the reaction we are seeing at this anode, that is giving up of an electron or losing an electron, this process is known as oxidation. Oxidation is a process of addition of oxygen or removal of electron. So here what is happening? One electron is going to get liberated or removed from this ion. So the oxidation process takes place at the anode. So two such radicals which are not stable are going to combine to form a stable chlorine gas liberated at the anode. Next, let us look at the reaction at cathode. The reaction at cathode. So what happens here? I have got sodium ions, Na plus ions, which are positively charged ions, which are not stable. If it wants to become stable, it requires or it wants one electron. So whatever the electron which is given by this Cl minus ions, we have that electron moves in this external battery, external source, and reaches the cathode plate. So this electron will be absorbed by this Na plus So Na plus takes this one electron and it becomes sodium atom, sodium molecule, sodium atom, which is a stable atom. So like this, what happens? Here the electron is removed from this ion. Such a process is called as oxidation, whereas that electron will be absorbed or taken by this ion Na plus, and this reaction is called as reduction. Reduction. So oxidation takes place at anode and reduction takes place at the cathode. So such a process of oxidation and reduction which takes in the electrolysis will be carried by splitting up of the ions, and then with the passage of these electrons in the external circuit. So here what happens? At the cathode, this Na, sodium, is going to deposit at the cathode. So after some time, if you see, if you open the cathode plate and see, some sodium metal is going to be deposited at the cathode plate. So we can measure it. So before the conduction, so you can measure the mass of the cathode plate, and after the conduction, so if you measure the mass, so you'll find out some difference in the masses of the cathode, which gives us the quantity or the substance, that is sodium, which is going to be deposited at the cathode plate. Next, we have Faraday's laws of electrolysis. Based on all this mechanism and Arrhenius postulates, Faraday has given his results in the form of two laws. So, first law, Faraday's first law. It tells that the mass of the substance which is liberated during electrolysis is directly proportional to the quantity of electricity that is passed. Means, if I pass more and more current, so obviously more quantity of the mass is going to deposit at their respective electrodes, and that is given as a Faraday's first law. So it tells that masses or mass of the substance deposited at the electrode is directly proportional to the quantity of charge. That is, if M is the mass of the substance and Q is the quantity of electricity or quantity of charge which is flowing through the electrolyte, then M is proportional to Q. And we also know that this Q is I into T. Quantity of electricity or quantity of charge is a product of current into time. So if I replace it, I can write the mass of the substance is directly proportional to I into T. Next, this proportionality symbol is replaced by, say, equal sign. We should put a constant. So that constant is Z in this case, where Z is called as ECE, that is electrochemical equivalent of that substance. Z is a constant of proportionality in this case, which is called as electrochemical equivalent of that substance. So what is that Z. How do we define Z? So by this equation, we can write Z as M by IT. Okay, so where I is the current and T is the time. If I take I as 1 ampere and T as 1 second, means when 1 ampere of current is passed through the electrolyte for a time of just 1 second, then your Z is equal to M. So this is how we define the ECE of the substance, which is nothing but the mass of the substance which is liberated or deposited at the cathode plate when a current of 1 ampere is passed through the solution for a time of 1 second. So Z becomes M when I is equal to 1 ampere, T is equal to 1 second. So what is the SI unit of Z? So Z is having an SI unit which is kg for mass, and for current ampere, and for time second. So kg per ampere per second is the SI unit of ECE of the substance, or it's also equal to kg per coulomb. Kg per coulomb, where coulomb is the unit of charge, Q. So kg per coulomb also the unit of Z. So this is about our first law of Faraday's electrolysis. Then move on to the second law. Second law. So in the second law, we have the electrolysis of more than one electrolytic cell. Say for example, I have got 1, 2, 3 different electrolytes. I got different electrolytes and electrodes which are placed in that. Say this is sodium chloride electrolyte, silver nitrate, copper sulfate, like this. When all these are connected in series, suppose I connect this with this, and this with this, and like this. So what happens? The electrolysis takes place in all these 3 different electrolytes, and after some time, see, if I pass the same current, for all these 3 different electrolytes, so we cannot expect the same quantity of the mass which is going to be deposited at their respective cathodes. So the masses of the substance which are deposited in this case are different, and that depends on their chemical equivalent weight. Chemical equivalent weight of that substance. So this is different for different substances. So if a electrolyte is having more chemical equivalent weight, then we'll have more deposition in their respective cathode. So masses of the substances which are deposited at the respective cathodes are proportional to the chemical equivalent weight of those substances when a same current is made to pass through the solution. So even though I'm passing the same current, so we cannot expect the same quantity of substances which are deposited. So that depends on their chemical equivalent weight. So M is proportional to E, where E is the chemical equivalent weight or just equivalent weight of the substance. So equivalent weight of the substance is nothing but the masses of the substance which are going to be combined with 1 gram of hydrogen. So if I have got different electrolytes, I can just write as M1 by E1. Say for first electrolyte, say sodium chloride, this is equal to M2 by E2. Further, this is equal to M2 by E3, means which is a constant. The ratio of the masses of the substances which are deposited at the electrodes to their chemical equivalent weights are constant. So that is what our Faraday's second law of electrolysis explains. So in the figure you can see that. So dilute sulfuric acid, the first, second say copper sulfate solution, the third silver nitrate solution are connected in series, and when they are having same current, so the series connection is having some rheostat to vary the resistance in the circuit. An ammeter is connected in the series to measure the current, and a plug key is inserted to switch on and off the circuit. So different electrolytes are having different chemical equivalent weights, and hence their masses deposited at the cathodes will be different. So that is from Faraday's second law of electrolysis. Next we have got the applications of electrolysis. So it has got a wide applications in industries. Say for an example, the first one is in industry, we use it for electroplating. Electroplating is nothing but the same thing. Electrolysis takes place. So whatever the substance which is going to deposit on this cathode plate, so that is a metal which is going to be fixed on that cathode plate. So the electroplating is used to coat one metal with another metal by using the electrolysis. So that is one of the application. So next, it is also used in extraction of the reactive metals. Extraction of the reactive metals. So reactive metals are the metals that occupy the top positions in the electrochemical series. So metals that are higher than zinc in electrochemical series are extracted using electrolysis. So these very reactive metals cannot be extracted by other metals such as reduction with carbon. So the reactive metals are obtained by electrolyzing a molten ionic compound of metal. Next, it is also used in the purification of the metals. So that is in the extraction or in the purification, whatever the metal which we are going to obtain will be of higher purity metal. So pure metal we will get it. So means we can have it as one of the application of electrolysis. So to purify, so the example which we have given is in the pure copper from a smelter is cast into a block to form the positive anode. The cathode is made of previously purified copper. These are dipped into an electrolyte of copper sulfate solution. When a DC current is passed through the solution, so electrolysis takes place and the copper anode dissolves forming blue ions, copper ions. These positive ions are attracted to the negative cathode and become copper atoms. So you can just see how we get pure copper in this electrolysis process. Some more examples of our electrolysis are, it is used in electrotyping, and it's also used in the purification of seawater, that is desalination of salt water, seawater. So like this, we have got different applications of electrolysis in industries. So the first part of our electrolysis, that is industrial chemistry, so is over. And thank you very much.